VAP number 7 coming at you, and it asks us to sketch the original graph given the graph of a derivative function. So we're given this function, the dark gray. So paying attention only to that, we can use characteristics of it, since it's a derivative function, to help us sketch the original function. So we can use a number line and compare the derivative function to characteristics of the original function. So from -2 to -1, we can see that it's below the x-axis, and this means that the slope of our original graph will be negative. And so from -1 to 1, it's above the x-axis, meaning that it'll be positive. And then once again, negative since it's below, and then back to positive. And we can also identify that going from a negative slope to a positive slope will result in a minimum, and going from a positive to a negative will give us a max, and then back to increasing once again, resulting in another minimum. So this will give us the direction of where our slope will be going when. And now we can use the double derivative to help us find the shape of our original function. So this second derivative is in this dotted line, and we can see that since it is above the x-axis from -2 to 0, it'll be positive. And this being a positive value means that our graph will be concave up in this domain. So, and then we see we have 0 at the origin, which gives us a point of inflection because it's going from above the x-axis to below. So it's going from positive to negative, and the negative shows us that it will be a concave down shape on our function. And then once again, we have another point of inflection at x equals 2, since it's returning to the positive, giving us another concave up shape. And also, we were given that f of 0 is equal to 2, so that gives us a starting point. And we were given a domain from -2 to 4, which is where we're working. So to sketch our parent function, we can use an integral of the derivative to return to the original parent function. So we can see that the slope of our original function can be the sum of the boxes below the x-axis. So this will be about 1. So we'll have a straight line of about, with a slope of about 1 right here, and we know that it's decreasing from our number line. Then doing the same thing, we say we have a slope of about 0.3, and we can return back to our given point. And then we can repeat this by shading under the x-axis to give us a bunch of straight lines, and then we can add in our shape, which we found in our second graph, or our second number line, I'm sorry, to help sketch the concave ups and the concave down. So we see that we're concave up from -2 to 0, concave down from 0 to 2, and then concave up from 2 to 4 once again. So now in this blue, we have our original parent function that we found using the derivative function.